Hello! In this video, we will be learning how to construct a simple LR0 or SLR parser. The L in LR stands for left to right, which is how the parser will parse the input, and the R stands for rightmost derivation, which is a style of bottom-up parsing. First, we have to understand what LR0 items are. An LR0 item is a production of the grammar with exactly one dot on the right-hand side. So here we have an example production rule, and that production rule leads to 4 LR0 items. The first one has the dot on the leftmost side of the right-hand side, and that is a non-kernel item. So if the dot is at the start of the production rule, then it's a non-kernel item, while the rest of them are kernel items. What is left of the dot has just been read by the parser, and the parser is ready to read the remainder after the dot. The next thing we have to understand is closures. Closures are an important part of making LR parser tables. You can pause the video right now in order to read about closures, but I think it's better to learn via example. Here is an example grammar that we will be using throughout the video. If we want the closure of set L, dot s, then we should see where the dot is located. Here, the dot is located right before the non-terminal symbol s. And we can see in our grammar that s has two production rules. The one that is open bracket L, close bracket, and the one that just ends with terminal symbol A. And we can insert that into our closure as a single line or as two separate lines. If in these two lines there is another non-terminal symbol after the dot, then we will repeat the process.
Now we will be creating the transitional state diagram, also known as the goto operations. Here we have our grammar, and before we do anything else, we must make it an augmented grammar. We do this so that we won't get the non-terminal symbol, the start non-terminal symbol, in this case s, in the right-hand side of the production rules. So in order to do that, all we need to do is just add another non-terminal symbol and add one production rule, which is this. So this will be the starting rule. And this is going to be our first state, I0. In our first state, we will be adding our starting rule, which is the s accent leads to s. Let me just, okay. And since we were supposed to have a dot here, and since this is a non-terminal symbol after the dot, then that means we have to add their production rules into the state. So we're adding the closures of s accent into this state. And so the rules from s would be s leads to open brackets L, close brackets, and A. Don't forget the dots. And here we have the first state, the I0. Now let's take a look at the dots. Here, our first dot here, what comes after it is a non-terminal symbol s. And so we can make a new state, I1, and we'll just delete this. And because this is after s, we move the dot, because it used to be like this. Now the dot is after the s, because we just went through it. So this is our second state. What next? The next dot is here, and we have an open bracket right after it, so we can make a new state. Let's see, I2, and goes to S, And the dot used to be here, but now it's after the bracket. Now we see that this dot here, after this dot, is a non-terminal symbol L. So we need to put all the production rules for L here. L, forget the dot. Here we have another dot, but that just goes to L, which is already covered here, so that's fine. Another dot here, and it goes to S. After the dot is S, and we don't have S here, so we need to add it to the state. S can go. And since we don't have any more non-terminal symbols after the dots, then that means we're done with this state. The next one, this dot here, after this dot is a terminal A. So we will make another state. This is state I3, and it goes to, the dot moves after the A. And since A is already a terminal symbol, then that means that we don't have to add anything else. Don't forget to add the text here. This is A. So when we input A, then it goes to this state. Now we go through each of these states, and we see here the first state, I1, it ends there, so that means that it's already accepted. And so we can't go anywhere else. On this second one though, on I2, we have this dot here goes to L. This is L2. Sorry, the comma is a terminal symbol. We have S here. It can go to S as well. It can go to the open bracket. It can go to the A here. So we're just going to go through each one by one. Let's see. If we go L here, and let's make this I4, because this is I3, so this is I4. And the dot should move to after the L, because this one is L. And this one doesn't apply anymore. And this dot here, because it's also L, so this dot also moves to here. And so the next step would be a comma. And S here doesn't apply. And there we go, because the comma here is the terminal symbol, there won't be any other additions to this state. The next one is this dot here, which goes to S. And we'll make another state, I5. And we'll delete this. And the dot used to be there, now it moves to after the S. And because this is the end of it, then that means there won't be any other additions. Let's add, this is S. And then the next one, here we have, after the dot is an open bracket. So we will make another one, an open bracket, 6. S goes to dot. But we see here that actually we've already done this before. With the dot after the bracket, we just get L again, which is what we did here. So we can actually just say that it loops back around instead of making another state. So we can just do this. So it loops back around when we give it open bracket. Next one is terminal A. Let's see. Terminal A would be this one. And it would go there. And because we've actually done this before in I3, so we can just delete this and make the arrow go into I3.
This is the finished transitional state diagram. When creating the parsing table, we need to reference the diagram that we've made before. And there are 3 rules that we need to follow. So the first one basically means that if there is an arrow from one state to another and action is a terminal symbol, then it's a shift operation on the parsing table. The second rule is if the arrow action is a non-terminal symbol, then for all of the follows of that symbol, it will be a reduce operation. The third one is if the dot is at the end of the starting rule, then it is an except action. And so, according to the rules that I've just explained, we need to know the follows of the non-terminal symbols S and L, as well as break down the grammar into reduce operations that we can use in the parsing table. And so this is the completed parsing table that we can make from the rules before. And I hope that you've learned something new from this video. Thank you for watching.